In this lesson you will learn about polygons and quadrilaterals. A polygon is defined as a closed figure that consists of line segments. This first figure is not a polygon because two of the sides are curved. This second figure is not a polygon because two of the sides pass through the figure. And the third figure is not a polygon because it's not a closed figure. These 2 points do not touch. And this third figure is not a polygon because it's not a closed figure. These 2 points do not touch. And these last 2 figures fit the definition of a polygon. Both are closed figures that consist of line segments. Once you determine that you have a polygon, you can group them into either concave polygons or convex polygons. To be a concave polygon, you need at least one side that when you extend it, it passes through the interior of the polygon. So this side, when extended, passes through the interior. This one does not, and this one does. So you don't need all of the sides that pass through the interior, just one to be considered a concave polygon. On the second figure, these sides pass through, and on the star, all of the sides, when you extend them, will pass through. Whereas on these 3 shapes, no matter which side I extend, none of them will pass through the interior, and that's why it's a convex polygon. A regular polygon is defined as a convex polygon where all of the sides have the same length and all of the angles have the same measure. So on this first figure, which has 6 sides, a 6-sided polygon is called a hexagon. To show that all of the sides are equal, I put dashes through each of the 6 sides, and to show that all of the angles have the same measure, I put a single arc through each angle. This next figure has 5 sides, and a 5-sided polygon is called a pentagon. So same thing, to show that all 5 sides are equal, I put single dashes through it, and to show that all of the angles are equal, I put single arcs through them. And this third figure has 4 sides, so it's a quadrilateral, but more specifically, it's a square. And we know that a square has 4 equal sides and 4 right angles. So polygons can be named depending on the number of sides. A 3-sided figure is a triangle, a 4-sided figure is a quadrilateral, 5-sided is a pentagon, 6-sided figure is a hexagon, 7 is a heptagon, 8 is an octagon, 9 is a nonagon, 10 is a decagon, and 12 is a dodecagon. So any number of sides that you don't see on this list, we call it an n-gon. So if you had a figure with 18 sides, we could call it an 18-gon. So we're going to look at more closely the different types of 4-sided figures, the different types of quadrilaterals. And the first type of quadrilateral is a parallelogram. And a parallelogram is defined as having both pairs of opposite sides parallel. And to show that sides are parallel, I draw the same number of arrows through opposite sides. In addition to both pairs of opposite sides being parallel, they are also congruent. The second type of quadrilateral is a rhombus. And a rhombus is a parallelogram, so we know that opposite sides are parallel and congruent, but it also has 4 equal sides. So I will show that by putting the same number of dashes through all 4 sides. A rectangle, again another type of parallelogram, has 4 right angles. And a square, another type of parallelogram, has 4 right angles and 4 equal sides. So all 3 shapes of rhombus, rectangle, and square are all types of parallelograms. So this means that a rhombus is a parallelogram because it has all the properties of a parallelogram. A rectangle is a parallelogram, and a square is a parallelogram. But a parallelogram is not necessarily a rhombus, a rectangle, or a square. On the next level, a square is a rhombus and a square is a rectangle, because a square has all the properties of a rhombus and a rectangle. A rhombus, though, is not necessarily a square, and a rectangle is not necessarily a square either. The fourth type of quadrilateral is a trapezoid. And a trapezoid is a quadrilateral with exactly 1 pair of parallel sides. So we don't classify a trapezoid as a parallelogram because it does not have 2 pairs of parallel sides, it only has 1 pair. And the pair of sides that are parallel I show with arrows, and these sides are called the bases. So we have a base on top and a base on the bottom. The 2 sides that are not parallel on a trapezoid are called the legs. No matter what type of quadrilateral you have, all of the measures of the angles inside the quadrilateral equal 360 degrees. So in a parallelogram, if I make this angle 60, its opposite angle is 60, and to get a sum of 360, then the other 2 angles would have to be 120. In a rhombus, if I made this angle 70, the opposite angle is also 70, and to get a sum of 360, the other 2 angles would have to be 110. A rectangle and a square, both of these shapes have 4 right angles, so we know that they're all 90 degrees. In a trapezoid, we know we have 2 bases that are parallel, and if I picked values for the angles on the top base, if I said this were 100 and this angle here were 150, these 2 angles are supplementary, which means they have to add up to 180 degrees. These 2 angles are also supplementary, so this angle would have to be 30. If you add up all 4 angles, you would get a sum of 360 degrees. So for questions 1 through 8, we just want to determine if the statement is true or false. So if a polygon is a trapezoid, then it is a quadrilateral. So a trapezoid has 1 pair of parallel sides, and a quadrilateral has 4 sides. So this is true. For number 2, if a polygon is a trapezoid, then it is a parallelogram. So a trapezoid has 1 pair of parallel sides, but a parallelogram has 2 pairs of parallel sides. So this statement is false. For number 3, if a polygon is a rectangle, then it is a quadrilateral. Well, yes, because quadrilaterals have 4 sides, so this is true. For number 4, if a polygon is a rectangle, then it is a parallelogram. So earlier, when we drew the hierarchy of quadrilaterals, we had a parallelogram and then a rectangle underneath it. So if a polygon is a rectangle, then it is a parallelogram is true because a rectangle has all of the properties of a parallelogram. If a polygon is a rhombus, then it's a square. So here we have a rhombus, and here we have a square. A square has all the properties of a rhombus. So if it's a rhombus, it is not necessarily a square. So this is false. If a polygon is a square, then it's a rhombus. Now this statement is true because the square is underneath, and the square has all of the properties of a rhombus. So this statement is true. For number 7, if a quadrilateral has 4 right angles, then it is a square. So we have two shapes with 4 right angles. We have a rectangle and we have a square. So if it has 4 right angles, then it is a square. Well, a square has all the properties of a rectangle, but a rectangle does not have all the properties of a square. So this is false. For number 7, if a quadrilateral has 4 right angles, then it is a square. So in our picture we had a rectangle on top and a square underneath. Both of these figures are the only two figures with 4 right angles. So if it has 4 right angles, then it is a square. So a square is a rectangle because it has all of its properties, but a rectangle is not a square. So this one is false. If a quadrilateral has 4 right angles, then it is a rectangle. This statement is true because a square has all of the properties of a rectangle, so we could also say that a square is a rectangle. So this is true. For questions 9 through 16, complete each statement using always, sometimes, or never. So a square is blank a rectangle. So again, I draw a rectangle, and then underneath it I draw a square, and a square has all the properties of a rectangle. So this is always. For number 10, a rectangle is blank a square. So same picture, we have the rectangle and the square, and the only way for a rectangle to be a square is if we have 4 equal sides. So this is only sometimes true. For 11, comparing a rhombus and a square, the square is underneath the rhombus, and for the same reason as number 10, a rhombus is only a square when it has 4 right angles. So this is only sometimes true. But when we reverse it, rhombus is always on top and a square is on the bottom. A square is always a rhombus because a square has all the properties of a rhombus. For number 13, comparing a trapezoid and a parallelogram, a trapezoid is never a parallelogram because to be a parallelogram you have 2 pairs of opposite sides that are parallel, and in a trapezoid you only have 1. So this is never. For number 14, a trapezoid is always a quadrilateral because trapezoids will always have 4 sides. For 15, a quadrilateral always has 4 sides. No matter what type of quadrilateral we're dealing with, whether it's a square, rectangle, parallelogram, rhombus, or trapezoid, it always has 4 sides. And for number 16, a quadrilateral sometimes has 4 right angles because the only 2 types of quadrilaterals that have 4 right angles are rectangles and squares. For number 17, we're asked to find the value of x, and we're given a quadrilateral. We don't know what type of quadrilateral, but knowing that it is a quadrilateral means that the sum of the angles is equal to 360 degrees. So I take my angles of 3x minus 30 and x plus 10 and 2x and 2x plus 20. I add them together and set them equal to 360 degrees. So when I add my x's, 3x plus x is 4x, plus 2x is 6x, and another 2x is 8x, and then negative 30 plus 10 is negative 20, plus 20 is 0, so I have 8x is equal to 360. So when I divide both sides by 8, I get x is equal to 45. For number 18, we have rhombus ABCD, where AB is equal to 3x and BC is equal to 2x plus 6. So if I draw a rhombus and label the rhombus as ABCD, you can start at any point you want, but make sure you label the letters going around in either direction. So A, B, I could only now put C here, and then D. We know that AB is 3x and that BC is 2x plus 6. And we're asked to find the length of each side of the rhombus. So when you're given quadrilateral problems, specifically for a rhombus, you want to think of the properties of a rhombus. And what we know about a rhombus is that we have 4 equal sides. And if all 4 sides are equal, then we know that the length of AB, which is 3x, is equal to the length of BC, which is 2x plus 6. So once we've determined an equation, we solve for x. And I get x is equal to 6. And to find the length of each side, I take AB is equal to 3x. So 3 times 6 is 18. And if I wanted to check this, I would take the length of BC, 2x plus 6, and substitute 6 in for x, and I get BC is equal to 18. And again, since we have a rhombus, we know that all 4 sides are equal, so each side is equal to 18. For number 19, find the value of x in the rectangle. So looking at this picture, we're only given one angle is 2x plus 10. But to solve this problem, you want to think of the properties of a rectangle, specifically the angles of a rectangle, because 2x plus 10 represents an angle. We know that the angles of a rectangle are all right angles, so that means that this angle of 2x plus 10 is equal to 90 degrees. So to find the value of x, I subtract 10 from both sides, and I get 2x is equal to 80, and then divide both sides by 2, so that x is equal to 40. For number 20, find the value of x and then classify the quadrilateral. So again, any 4-sided figure, we know that all of the angles have to add up to 360 degrees. So I take my four angles, 5x minus 15 plus 4x minus 30 plus 2x plus 60 plus 3x minus 5, and set the equation equal to 360 degrees. So I start by combining my x's. 5x and 4x is 9x, plus 2x is 11x, plus 3x is 14x, and then I have negative 15 minus 30 is negative 45, plus 60 is 15, minus 5 is 10. It's positive 10, so I add 10, set it equal to 360, and then continue with solving for x by subtracting 10, so that 14x is equal to 350. I divide both sides by 14, and if I take 14, divide it into 350, (14 times 5 is 70), so x is equal to 25. So I found the value of x, so that's the first part of the question, and then we want to classify the quadrilateral. So to classify the quadrilateral, we need to find what the angles are equal to. So let's start with 5x minus 15. So with 5x minus 15, I take 5 times 25, and then subtract 15, and 125 minus 15 is equal to 110. So this angle here is 110 degrees. The next angle I'll check is 4x minus 30. So I take 4 times 25 minus 30. 4 times 25 is 100. 100 minus 30 is 70. So this angle is 70 degrees. Next I'll check 2x plus 60. So I have 2 times 25 plus 60, and 50 plus 60 is equal to 110. And last, 3x minus 5. Just substitute 25 in for x, and 75 minus 5 is equal to 70. So in this quadrilateral, we have opposite angles that are equal, so that means we have a parallelogram. So x is equal to 25, and the type of quadrilateral is a parallelogram.